Hi, everyone. This is Mr. Bryce, and we are continuing. This is lesson 2 with our slam dunk. We are in January of 2018, I believe. Could be January 2016. It's not here on the bottom of the page. Let's go up. January 2018. We're doing number 10. We're only doing the questions that are slam dunk. They're the easy ones. You can do most of them with your calculator. Given the parent function f of x equals x cubed, the function g of x equals parenthesis x minus 1 cubed minus 2. So that's an exponent of a 3. We start with the parent function and we do some stuff to it. Where does it shift? Well, please just go to y equals and graph x cubed, and then on y2 you do x minus 1 cubed minus 2. So what I did here was I typed in the equation into y equals. Well, I did it into Google graphing, but you can do it into y equals. And what I want you to notice is that here is the point of inflection, and here is the point of inflection. So it moved 1 to the right and 2 down. Not a coincidence. It moved 1 to the right and 2 down. You can see the same thing on your graphing calculator, but it moved 1 to the right and 2 down. Just use your tool, your graphing calculator. Number 13. So this test is kind of strange because usually it's 1 through 8 and then skips out. The height of a ball during toss in the air can be modeled by the function negative 4.9x squared plus 6x plus 5, where x is the time lapsed in seconds and h of x is the height. So now we know that h of x, which is also known as y, is the height and the meters, and we have time. The number 5 in the function represents, the number, cut that out. I really preferred Smartboard, but we switched over to a different one, and so now I have to use Cami. Okay, so the number 5 represents what? Well, it represents the y-intercept. 1, 2, 3, 4, 5. The ball gets tossed up in the air and down. So, what do you think 5 is? Since we graphed it and sketched it right there, the 5 is the initial height because x is time and y is height. H of x is height, which is another name for y. It's 5 feet off the ground. Initial height, that's the starting value, 0, 5. If you plug 0 into the equation, out pops a 5. 0 is the time, 5 is the height, how high the ball is. Number 14, the function f of x equals 2x squared plus 6x minus 12 has a domain. Those are the x values consisting of the integers from 2 to 1. Negative 2, negative 1, 0, and 1. Inclusive, that means that we are including those numbers. So this is vocabulary. Which set represents corresponding range for f of x? So what I do is I go to y equals in the calculator, type in 2x squared plus 6x minus 12. It's a lot easier that way. and I find out what the y values are. How do I find out what the y values are? I type it into y equals, I hit second graph, which shows me the table. I scroll up or down until I see -2 on the x spot and the y spot says -16. You better be doing this. And then -1 also has -16. 0 has -12 and 1 has -4. Now we're not going to repeat -16. So we have -16 once, we have -12, and we have -4. So I could cross off choice number 1 and 3 because they have an extra number in there, -32. To summarize again, I went to y equals, I plugged in the function, I knew the domain was the x value. I only looked at the table for -2, -1, 0, and 1. I looked for the y values. I don't write down anything that repeats. Number 17, the function f of x is graphed below. Okay, listen. It comes to a v with a vertex. That means it's an absolute value function. I notice that there's no arrow there, but it's filled in, but there is an arrow there, so it continues. That means it has a limited domain. The domain of this function is not all positive real numbers, because here are the positive real numbers here. Those are negatives. I have to have some negative numbers in the domain because they're there. All positive integers, definitely not, because the integers are 1, 2, 3, 4. So that would look like a 1, a 2, a 3, and a 4. No connection to them. All x is greater than 0? Nope. All x is greater than or equal to -1. Let's take a look. Is this at -1? Yes, it is. It's filled in, so it has to have the equal to sign. It is choice 4. When we're looking at this, we have to just remember that positive real numbers are all fractions and decimals, as well as whole numbers, mixed numbers, square roots. Integers are just, it said positive, but I'm just going to define what integers are. Positive integers are the green. All integers are all of them. Let's go on to the next part. Eraser. Which pair of equations would have -1, 2 as the solution? What do you think you want to do? What I want to do is I want to go and type in y1 as x plus 3 and y2 as 2 to the x. And look at the table. -1, this is going to be x. This is going to be y1. That's going to be y2 on our calculator. And for the first one, for -1, we get 2 as an answer. For that one, we get 1/2. No. Then we rinse and repeat, meaning the next equation is x minus 1 and 2 to the x. We type them in to our calculator. We look at the table, and when I plug in -1, I get out -2, and I get out -2. It's choice 2. Don't stop. Do the next one. Why? Make sure you didn't make a mistake. X squared minus 3x minus 2 and 4x plus 6. We go to, those are typed into y equals. We hit second graph. We hit second graph to get the table. And when we look at -1, we get 2. When we look at this one, hang on a second. Now I'm going to have to use my calculator because I'm using my brain right now. So it would sound like that I did that intentionally, but I did not, because this one actually gives me a -2 as the solution, not a +2. So that one's wrong, that one's right, that one's wrong. Type them into y equals, take a look at the table. They have to have that solution at -1 for the x, has to have 2 for the y. The function f of x, q of x, and p of x are shown below. F is the graph, q is the quadratic, and p is the table. When the input is 4, which functions have the same output value? When the input is 4, 1, 2, 3, 4, the output is 1, 2, 3. So this is 4, 3. This is 4, 3. So far, the graph and the table have the same one. Let's plug in 4 into that, into your calculator. You type it in exactly the way that looks. This is 9 minus 6, which is 3. How about that? They have 4, 3, 4, 3, and 4, 3. All of them have the same output. Materials A and B decay over time. The function for the amount of material A is 1,000 times 1/2 raised to the 2t. That's A of t. For the amount of B, the function is 1,000, 0.25 or 1/4 raised to the t. On which day will the amounts of material be equal? Go to your calculator, type both of them into the table right now, into y equals. I'm typing into y equals. I want you to be typing into y equals. Remember, the exponent is the caret. It's the key right above the division symbol on the right-hand side. You have all the white keys going up, and then you have the caret key, the exponent key. We don't have an x, we don't have a t, so we just type in 2x. And then the other one is 1,000 and 0.25 with an exponent of still x. Look at the table. Second graph, you look at the table, every single one in y1 and y2 is the same. So the answer is every day. Okay, this is Mr. Bryce. I'll see you in the next video when we will go to August of 2018. If you have any questions, make sure you ask. Email me,